In this video, we'll be discussing about file and directory maintenance in Unix. Let us see the contents first. File access function, file controls and directory maintenance. File access function. In this, we will discuss some file functions that are used to perform various operations on the file. They are open function, create function, write function, read function and close function. Let us start with open function. The open function establishes the connection between file and a file descriptor. The open function returns a file descriptor for the named file, that is the lowest file descriptor not currently open for that process. The open file descriptor is new and therefore the file descriptor does not share it with any other process in the system. The function action header file required and the syntax of the open function are as follows. Function action opens a file. Header file required sys/types.h, stat.h and fcontrol.h, and the syntax is as follows. It consists of path, oflag and mode. The file offset used to mark the current position within a file is set to the beginning of the file. The file status flags and file access modes of the open file descriptions are set according to the value of oflag. The following list includes some commonly used flag values. They are read only, open for reading only, write only, open for writing only, read write, open for reading and writing, non-block, do not block on open, append, append on each write, create, create file if it does not exist, trunc, truncate size to 0, exel, error if create and file exist, direct, eliminate or reduces cache effects, and fsync. For example, to open the file temp.txt in the current working directory for reading and writing, we can use this, which consists of the file name and the mode. To open sample.txt in the current working directory for appending or create it, if it does not exist with read, write and execute permissions for owner only, then we can use this, which consists of all of this. A file may be opened or created outside the current working directory. In this case, an absolute path and relative path may prefix the file name. For example, to create a file name in /tmp directory, then we can use this. Return values. Upon successful completion, the open function opens a file and returns a non-negative integer representing the lowest numbered unused file descriptor. Otherwise, -1 is written, no file are created or modified. One deficiency with the create is that the file is open only for writing. Before the new version of open was provided, if we were creating a temporary file that was wanted to write and then read back, we had to call create, close and then open. A better way is to use the new open function as in this, which consists of the path name and these functions along with mode. Next one is create function. Create. It creates a new file or rewrites an existing one. The header file required sys/types.h, stat.h and fcontrol.h. The syntax is as follows, which consists of the path name and mode. The next one is write function. Write. Writes on a file. Header file required #include unisted.h and the syntax is as follows, which consists of fields, buffer and n byte. Description. It writes n bytes of data to the file referenced by the file descriptor fd from the buffer pointed by buff. The write starts at the position pointed by the offset of the file. Upon returning from write, the offset is advanced by the number of bytes which were successfully written. The function returns the number of bytes that were actually written, or it returns the value -1 if failed. Next one is read function. The function action header file required and syntax of the read function is as follows. Read reads from a file. Header file required is same, that is unisted.h, and the syntax is as follows, which consists of fields, buffer and n bytes, which is same as write. Last one is close function. Close is a file descriptor. Header file required, hash include unisted.h. Syntax, it's very simple, that is int close and int fields. This close function returns the value 0 if successful, otherwise the value -1 is written. Here we end up with our functions. Now let us see an example for this. How to open, read and write to the buffer a particular file. So the solution for this particular problem is, we open a file using the open function first and then write it in the buffer using the write function. First, we open that particular file whose file name is passed as an argument by the user. Means the user will send an argument. Then we write the contents to the file typed by the user as a standard input using the fgetters function, and finally print it using the printf function. As last, we close the file using the close function. Now let us see the execution of this particular program. Let us see the example now. It is an example which will show how to open, write and close the file. Here we can see the open function, which consists of arguments. If the file is not there, then it will produce an error. Otherwise, you have to enter the string. It will take the string from the user and it will count the number of bytes of that particular string. Then it will return the number of bytes. Then it will close the file. Let us see now. Let us execute it now. gcc open.c gcc open.c /a.out. Here I have to pass the argument, that is the file name. Consider the file name is a.c. Here we have to enter the string. So whatever you want you can enter. Swati, enter. So here Swati 1 2 3 4 5 6 bytes written into this file along with the space. We can see this is the output. If you haven't given any, if you don't give any argument, then it will produce bad address. So this is the example. The next one is file control function. Here we are discussing about the activities performed in the file control and input output control on the descriptor. The functions here we are discussing are fcontrol, lseek, stat, fstat, lstat, dupe, dupe2 and ioctl. All functions in this module take a file descriptor fd as their first argument. Let us start one by one. The first one is fcontrol function. Performs the operation op on the file descriptor fd. The values used for the op are operating system dependent here. The argument r is optional and the defaults to the integer value is 0. When the argument is a string, it represents the binary structure. The return value after a successful call is the contents of the buffer. So the function actions header file required and syntax of this fcontrol function is as follows. It is used to control the file. Header files required is unisted, and the syntax consists of fields, change mode, and it also consists of the operation with arguments. The file control functions, it performs the requested operations on the open file. These are the requested operations. Go through this. According to this, the written values are obtained. Upon successful completion of the fcontrol function, the values returned shall be as follows. If it is dupefd, then a new file descriptor will be written. If it is getfd, value of flags defined in the fcontrol, the return value should not be negative. If it is setfd, then the value other than -1 will be returned. The next one is lseek function. This function is used for positioning a file descriptor and move the read-write file offset. This function allows the file offset to be set beyond the end of the existing data in the file. Function action for this lseek is lseek. It moves the read or write file offset, header file, unistate.h, and the syntax consists of fields, offset, and whence. The lseek function sets the file offset for the open file description associated with the file description fields as follows. Here, if the whence is seek set, then the file offset is set to offset bytes. If whence is seek curt means seek current, then the file offset is set to its current location plus along with that offset. If whence is seek end, then the file offset is set to the size of the file plus offset. Let us see the written values. After successful completion of the lseek function, the resulting offset as measured in bytes from the beginning of the file is returned. Otherwise, -1 is returned. Error number is set to indicate the error and the file offset remains unchanged. The next one we are going to study are stat, lstat, fstat functions. They are kind of similar. The first one is the stat. The stat function obtains information about the file pointed to by the path. Read, write or execute permissions of the named file is not required here, but all directories listed in the path name leading to the file must be searchable. Coming to the lstat. The lstat function obtains the file attributes similar to stat except when the named file is a symbolic link. In that case, lstat returns information about the link while stat returns the information about the file, the link reference. The last one is the fstat. It obtains information about an open file known by the file descriptor fields obtained from a successful open, create, dupe, fcontrol or function. Now let us see the function action, header file and syntax for these. The function action is get file status. The header files are types.h and stat.h. And the syntax for these three are as follows. For all of this, it consists of path and buffer, and for the fstat, it consists of fields and buffer. The next one is the dupe function. The dupe function. It returns the new file descriptor having the following features, and the features are same open file, same file pointer, same access mode. The new file descriptor is set to remain open across the execute function. Let us discuss the header file and the syntax for this. So the function action for dupe is it duplicates an open file descriptor. The header file is unistate. The syntax is very simple, that is int dupe and int fields, which consist of int fields in it. Return value. After completion of the dupe function, a non-negative integer representing the file descriptor is returned. Otherwise, -1 is returned. Dupe2 function. The dupe2 function causes the file descriptor fields2 to refer to the same file as fields. Function name dupe2 duplicates an open file descriptor. Header file required. Unistate.h. Syntax. It consists of fields and fields2. Return value. After successful completion, a non-negative integer representing the file descriptor is returned. Otherwise, -1 is returned. The next one and the last one is loctl function. It performs a variety of control functions on the devices and streams. For non-streams file, the functions performed by this call are device-specific control functions. Let us see the function action syntax and the header files. Function action. It controls the device. Header file required. Unistate.h and stops.h. Syntax. It consists of fields, requests and arguments. Return values. The values returned depends on the device control function, but it must be a non-negative integer. Now let us move on to the directory maintenance. This module performs file control and input-output control on the directories. Topics covered here are change mode and change owner. Let us start with change mode function. The change mode function consists of the function action which changes access permission mode of the file. Header file required are sys/types.h, sys/stat.h, and the syntax consists of path and mode. Access permission bits are interpreted as below. Please go through this. Modes are constructed by the bitwise OR operation of the access permission bits. If a directory is writable and has isvdx file, within that directory can be removed or renamed only if one or more of the file is true. The user owns the file, the user owns the directory, the file is writable by the user is a privileged user. Return value. After successful completion of the change mode function, 0 is returned, otherwise -1 is returned. The next one is change owner function. The change owner function changes the user and group of the file. The path argument change owner function points to a path name naming a file. The user ID and group ID of the named file are set to the numeric values contained in owner and group respectively. Function action changes owner and group of the file. Header file required unistate.h. Syntax, it consists of path, uid owner and gid group. Return values. Upon successful completion of the change owner function, 0 shall be returned, otherwise -1 shall be returned. By this I conclude my topic. Thanks for watching this video. Please do comment and like. Thank you.